Hello, it's been a while since we recorded a lesson or a video, whatever you want to call it. Today I have a very interesting video for you, or a record for you, which talks about convergence or unit convergence that is related to volume, and using the ratio or the scale factor with areas, because we cannot separate what we learned about numbers and working with numbers, which includes ratio, from the new subject that we are learning this term. Okay, so let's start at first with this question here. The mass of a lorry is 44 tons and the mass of a boat is 3. So as you are reading a word problem, you must put here lorry and you have a boat. So they say that the mass for the lorry is 44 tons, and for B, the mass is 35,000 kilograms. Which one is heavier? In order to compare between them, we need to make sure that the measurement units are the exact same for both objects. Accordingly, there is a fact that states that every 1 ton is equal to 1,000 kilogram. Accordingly, 44 tons. So we place tons under tons. So this will be my unknown. I'm going to cross multiply to find my unknown. So x is equal to fraction line. What is the x multiplied by? It's multiplied by 1. What are the other two numbers? 44 and 1,000. They go up, multiplied by each other. Accordingly, this is equal to 44,000 kilograms. And so we can say here that the mass is equal to 44,000 kilograms, and the mass here equals to 35,000 kilograms. And now I can compare between them using the sign less than, greater than. So 44,000 kilograms is greater than 35,000 kilograms. Okay, let me here split our work so that you can follow up on the work. And at last, we compared between the two masses after we performed the unit conversion. Okay, I don't like you to memorize like from a smaller unit to a greater unit we do blah blah blah. You must state the fact, and the fact says that every 1 ton is equal to 1,000 kilogram. Okay, I decided to convert the 44 tons. So where shall I place it? I place it underneath tons. So my unknown is the kilograms. Once I place the numbers in this order, I apply cross multiplication. So x is my unknown equals to fraction line. What is my x multiplied? It's multiplied by 1 ton. What are the other two numbers that we are multiplying? 44 and 1,000. And accordingly, 44 tons is equal to 44,000 kilograms. I can now compare between the two, and I can put the final answer as 44 thousand kilograms is greater than 35,000 kilograms, which means that the lorry is greater or is heavier than the boat. Okay, calculate the following. How many kilograms are there in 4.5 tons? So again, we're going to place the fact, which is 1 ton is equal to 1,000 kilogram. What is given in the question? 4.5 tons. So I must place it underneath tons. So 4.5 tons is equal to how many grams? This is my unknown. So I now going to perform cross multiplication. So x is my unknown equals to fraction line. X is multiplied by 1. The other two numbers are 4.5 times 1,000. So when you multiply 4.5 times 1,000, you're going to move the decimal towards the right 3 places. So it's 4 here and 1, 2. So the answer will be 4,500 kilograms. So in 4.5 tons, there are 4,500 kilograms. And that's how we do unit conversions. Okay, let's move to next. How many grams are there in 0.2 tons? Okay, let's put the facts that we know. I'm going to put the fact in green. We know that every 1 ton is equal to sorry about that. It's equal to 1,000 kilogram. Perfect. What's given in the question? What's given in the question? 0.2 tons. So I must place it underneath the tons is equal to, this is my unknown. Now I'm going to cross multiply. So x is my unknown equals to fraction line. What is the x multiplied by? It's multiplied by 1. What are the other two numbers? 0.2 times 1,000. So 0.2 times 1,000, the answer will be so it will be 200. So 200, and the measurement unit is kilograms. But they're asking for it in grams. So there is another fact that we must state here. So there is another fact, sorry for the interruption, which states that every 1 kilogram is equal to 1,000 grams. Perfect. So now we found our unknown, which is the 200 kilograms. So we must place it underneath kilograms equals to, and this is my new unknown. And then I'm going to cross multiply. So my unknown is y equals to fraction line. Y is multiplied by 1, so the 1 will go down. The other two numbers, 200 and 1,000, they will go up, multiplied by each other. Accordingly, y is equal to 200,000 grams. So the answer for this part here, how many grams in 0.2 tons? It will be 200,000 grams. Okay. All right. How many milligrams are there in 30 in 30 grams. Okay, so we're going to state the fact at first. So every 1 gram is actually equal to 1,000 milligrams. So milligrams is mg and grams are grams. We know that, right? So what is given to us? 30 grams. So I'm going to place the given number, which is 30 grams, underneath grams, equals to, this is my unknown. And then I'm going to cross multiply to find the unknown. So x is my unknown equals to fraction line. X is multiplied by 1, so the 1 will go down. The other two numbers, which are 30 and 1,000, they will go up, multiplied by each other. So it's 30 times 1,000. And 30 times 1,000, it's 30,000 milligrams. Okay, 30,000 milligrams. So the answer here, how many milligrams in 30 grams? It's 30,000 milligrams. Okay, let's have a look here at problems that involve calculations of volume and unit conversion with volume. So they're telling us that every 1,000 centimeter cubic of water is equal to 1 liter. So these are facts. So the fact is 1,000 centimeter cubic of water is equal to 1 liter. And 1 liter of water, so 1 liter of water is or equal, has a mass or equal to 1 kilogram. So all these facts are given to us in the question. Calculate the mass of water that would completely fill each of these containers and give your answer in grams. So when they ask you to calculate the mass, it means calculating the volume. And to calculate the volume of this rectangular tank or prism, right? It's equal to area of the base times the height, which is equal to, the base is the side that is sitting on the floor and it is a rectangle, and the area for it is 2 times 8 times the height between the floor and the ceiling, the distance between the two typical bases. So if we choose the base that is sitting on the floor, then we must choose a typical base to it, which is the ceiling, and the distance between them is 4 centimeters. So it's times 4. We must also know that all numbers have the exact same measurement unit. So if you calculate here, 2 times 8 times 4, 2 times 8 times 4, okay, it will be 64 centimeter cubic. Okay, 64 centimeter cubic. So in addition to the facts that are given to the question, we know that every 1 kilogram is equal to 1,000 grams. right? So if I want to place the kilogram here with 1,000 gram, this will be equal to 1 liter. In other words, 1,000 gram is equal to 1,000 centimeter cubic, right? So from this and this, I can conclude a fact that 1,000 centimeter cubic is equal to 1,000 gram, right? Now, what is it that we found? We found 64 centimeter cubic, and this is my unknown. I'm going to cross multiply. So x is my unknown. I will put x here is equal to fraction line. X is multiplied by 1,000, and the other two numbers, which are 64 and 1,000, are gonna go up multiplied by each other. So basically, the answer in grams will remain as 64 grams. Okay, and here we have a cuboid once again, or a rectangular prism, where the dimensions are given in millimeters. And if you read once again the given informations, so it will be 1 centimeter cubic is equal to 1 liter, and 1 liter is actually equal to 1 kilogram. And we said earlier, every 1 kilogram is equal to 1,000 gram. This is something that you should never ever forget. So if you want to place the 1 kilogram with 1,000 gram, this will be equal to 1 liter. And 1 liter is, if I want to place the 1 liter with 1,000 centimeter cubic, this means that this is equal to 1,000 gram. Okay, we're just making a relation between centimeter cubic and liters, kilograms and liters, grams and liters, and then grams and centimeter cubic. Okay, so we need to calculate the volume of this prism. So the volume of the rectangular, first of all, I can calculate it in two ways. I'm going to explain the two ways, and you choose the way that you feel more comfortable with. So we're going to say the volume of the rectangular prism is equal to area of the base, which is the base that is sitting on the floor, times the height or the distance between the two identical bases, which are the floor and the ceiling. Okay, so it's equal to, so this is my base. So the area of this one, it will be 8 times 28 millimeter times the height between the floor and the ceiling, or we call them the two identical bases. The distance between them is 14 millimeter. So 8 times, sorry about this, 8 times 28 times 14, it will be 3,136. And remember, the measurement unit is millimeter cubic or cubic millimeter. Okay, if we want to convert it to centimeter cubic, remember, there is a fact 1 centimeter is equal to 10 millimeter. And if we want to make it cubic, we're going to take all this to the power of 3, which means 1 times 1 times 1. So it's 1 to the power of 3, and here it will be centimeter cubic is equal to 10 times 10 times 10, which is 10 to the power of 3 or 1000 millimeter cubic. What is it that we found? We found the 3,136 millimeter cubic. So we place it underneath millimeter cubic. 3136 millimeter cubic is equal to, and this is my unknown. And I'm going to cross multiply to find the unknown. So x is equal to fraction line. What is the x multiplied by? It's multiplied by 10 to the power of 3, or it's equal to 1,000. And here it will be 1 to the power of 3, which is 1, times 3136. And the answer will be in centimeter cubic. The answer will be 3136 divided by 10 to the power of 3. It will be 3.136 centimeter cubic. Okay. The other way that I wanted to tell you about is, so we stated a fact that every 1 centimeter is equal to 10 millimeter, right? So we're going to divide this by 10. So it becomes 1.4 centimeter. And if we divide this by 10, it will be 0.8 centimeter. And if we divide this by 10, it will be 2.8 centimeter. So the volume here, you can use it as a method to check on the work. It will be area of the base, which is 0.8 times 2.8 times the distance between the two identical bases, which is 1.4. And if you multiply these numbers together, you will end up with 3.136 centimeter cubic, which is the exact same number that we found. So you can use this as a checking method. Okay? Let's move to the next question. The mass of 1 meter cubic of water is given as 1 ton. So this is a fact that is given in the question. So 1 meter cubic is equal to 1 ton. Okay, the mass of 1 liter of water, and we can write this fact as well. 1 liter is equal to 1 kilogram. Perfect. The diagram below shows a water tank in the shape of a triangular prism. Calculate the mass of water that could fill this tank. In other words, calculate the volume of the triangular prism. So I'm going to start by writing volume of the triangular prism is equal to area of the right angled triangle times the height or the distance between the two right angled triangles. Okay, let's apply this rule. Make sure that all numbers are in the exact same measurement unit. So equals to Let me keep the rule in black so that you can always remember it, and I will carry on here with this color. So the area of any triangle, it is half times the base is 5.5 times the height is 2. So this is the area of the triangle times the distance between the two right angle triangles is 3. And if you insert all this in the calculator, you will find the answer as you will find the answer as, so it will be here, 0.5 times 5.5 times 2 times 3. The answer will be 16.5, and the measurement unit is meter cubic because we are calculating the volume. Okay. Let's go now to this part here. So this one is related to the subject of using ratio and scale factors with area. So here we have a small rectangle and a big rectangle, okay? So two rectangles are shown below. One is an enlargement of the other by a scale factor of 3. So what is given here? The scale factor. So the scale factor is equal to 3. Okay, I'm going to work this example as following. So we have the small rectangle and we have here the big rectangle. And if I call this as small b, then this will be the small height. Okay? Okay, so b is equal to 9 and h is equal to 4. And we have in between the scale factor, which is equal to 3. So the scale factor, which is equal to 3. And since the big rectangle is an enlargement of a small rectangle by 3, then we're going to multiply b by 3. That's what it means, the scale factor, and h by 3, which means that the base of the big rectangle, so this is b, and this is the height, it will be 9 times the scale factor, which is 3. And the answer will be 27. And it's centimeters, remember. And here, you're going to say that the big H is equal to the small h times the scale factor, which is 3. And this is equal to 12 centimeter. How about we write this as a formula? So the small b is equal to the big B divided by 3. Am I right? Or it can be written as the big B is equal to 3 times B. So as you can see, we cannot separate ourselves from algebra, from ratios, from scale factors. Whatever you learn must be always connected with each other. So here is the formulas. If they ask me to write a formula that connects B and small b and big B, same applies to the exact same thing, which is h, small h and big H. Okay, let's carry on. So what is it that calculate the area of the enlarged? Okay, what if we want to calculate the area for the small rectangle? It will be 9 times 4 base times height, and the answer will be 36 centimeter squared. If I want to calculate the area of the big rectangle, it will be as well base times height. So the base is 27 times 12, and the answer is, so 27 times 12, the answer will be 324 centimeter squared. Okay, perfect. If we want to write a formula between A small and A capital, so we're going to say that A small is equal to A capital divided by A capital divided by 16. How did I know that? How did I know that? Okay, let's do a ratio A small to A capital. So A small is basically equal to 36 sorry, here it's 9. I'm sorry. It's 9. Okay, so 36, and the area of the big rectangle is 324. And as we learned, if we want to simplify all this, we're going to divide each number in the ratio by 36, right? So this will become 1 to 9, because 324 divided by 36, it will become a 9. Okay, so this is very important to remember in order to know how did we find. So we write the formula between A small and A capital as A is equal to A over 9, or we can say A capital is equal to 9 times A small, or 9A small, and that's how we write the formula between A small and A capital. Okay, let's move to next. Two rectangles are shown below. One is an enlargement of the other by scale factor of 3. Calculate the length of the diagonal. So they want us to calculate the length of the diagonal. So we're going to do the exact same thing. What's given to us is the scale factor that is equal to 3. And here we have the small rectangle and the big rectangle. And as we named earlier, we're going to call this as the small base or B small, and this is H small. So here H small is equal to 4 centimeter and B small is equal to 9 centimeter. Okay, and we have the scale factor which is equal to 3, and accordingly we concluded that big H is equal to the small h multiplied by the scale factor which is 3 because it's an enlargement. So the big H will come down to 12 centimeter. And we do the exact same thing for big B is equal to small b, which is 9, times the scale factor, which is 3. And this will come down, or b will come down to 27 centimeter. In order to calculate the diagonal, let's calculate the diagonal for the small rectangle first. We are going to use Pythagorean theorem. Let's call the diagonal as small d. So d squared, the hypotenuse to the power of 2, equals to h squared plus b squared. And this is Pythagorean theorem that you learned. Okay, the diagonal to the power of 2 or the hypotenuse to the power of 2, we square each of the perpendicular sides and we add them. So d squared, let's substitute here. So d squared is equal to 4 squared plus 9 squared, and d is equal to square root of 4 squared plus 9 squared. And if you insert this in the calculator, you will find d as, okay, so it's the square root of 4 squared plus 9 squared, and the answer is square root of 97. Let's leave it this way, and the measurement unit is centimeter. Let's do the exact same thing for the big rectangle. So here we're going to find the diagonal or the hypotenuse. So if we go up here, so this is big D, this is the big B, which is equal to 27 centimeter, and this is the big H, which is equal to 12 centimeter. So, and this is the right angle triangle. So the Pythagorean theorem states that the hypotenuse, which is d in here, to the power of 2 is equal to h squared plus b squared. So it's equal to h squared plus big B squared, and it's squared here. So it's equal to, let's substitute. So h, big H is 12 squared plus B, big B is 27 squared, and this is D capital squared. We are trying to find the D, so it will, let's square root each side. So it's square root of 12 squared plus 27 squared. And if you insert this in the calculator, square root of 12 squared plus 27 squared, and this is equal to 3 square root of 97 centimeter. If they ask us to find a formula between D small and D capital, so we're going to say that D capital is equal to 3 times D small. Am I right? 3 times D small. Or we can say that D small is equal to D capital divided by 3. And that's how we write a formula between D capital and D small. Okay, and if they ask us to find the ratio between D small and D capital, we're going to say here D small to D capital. So D small is square root of 97 to 3 square root of 97. So in order to simplify this, we're going to divide each by square root of 97. So this D, small d, will come down to 1 to 3. And that's how we find the ratio of D small to D capital. Okay. We have two trapeziums here, A and B are shown. B is an enlargement of A. The area of trapezium B is, so the area of trapezium B is 256 centimeters squared. Okay. We're going to do the exact same thing that we did previously. So here we're going to say small. I'm going to give it a short name as trapezium, and big trapezium trap here. Okay. What properties do we need from trapezium in order to calculate the area? Okay. So here we're going to say we need the two parallel sides or bases. So if I call this B1, it has no numerical value. It's just part of the name. So B1 is equal to 3 centimeter and small b2 is equal to 5 centimeter. What is missing here is small h, right? And I'm going to call this as, what is missing here is the big, or B1, capital B1 is unknown, and capital B2 is equal to 20. I'm going to call this from here to here as capital H, okay? And the area is given to us as 256 centimeter squared. And the area of the small trapezium is unknown. Perfect. Now that we identify what is given and what is the unknown, we can start working out. So B1 is equal to 3 centimeter, while B capital 1 is unknown. So B2, the other parallel side to B1, is equal to 5 centimeter, and B2 is equal to 20 centimeter. can we make a relation between B2 and B1, small b2 and small capital B2? So we're going to say that B2 is equal to 4, is equal to 4 times B2. How did I know that? Okay, let's do that together. So you're going to say B, small b2 in proportion to capital B2. This one is 5 to 20. Simplify by dividing each by 5. So 5 divided by 5 is 1, and 20 divided by 5 is 4. That's how I know, or how I can make a relation between B2 small and B2 capital as a formula. So, or we can say here, or the formula can be written, B2 capital is equal to, oh, I'm so sorry, we have a mistake here. So here you're going to say B small is equal to B2 capital divided by 4. Okay? Or we can write it as, and we understood where did the 4 come from, or we can say that B2 capital equals to 4 times B2 small. Okay? So that's how we write the formula here. Okay. Next. What's given as well is, oh, none of the H's are given, right? But we know that the area here is equal to, or is given to us as 256 centimeter squared. 256 centimeter squared. And the area of the trapezium equals to half of the addition of the two parallel bases, so B1 plus B2 times the distance between the two parallel bases. So once again, area of the trapezium is half times the addition of the two parallel bases. This side is parallel to this side. So the addition of B1 plus B2 times the vertical distance between the two parallel bases, or the two parallel sides, which is H here. I just forgot to mention one thing here. Since we figured out a relation between B2 small and B2 capital, it is also applicable on B1 small and B1 capital. So in order to find this one here, we're going to say it's equal to B1 is 3, and we're going to multiply it by 4 in order to find B1 capital. So this one will come down to 12 centimeter. Okay. So let's substitute here now. We can replace that 256. So area is equal to 256 equals to half. B1 is equal to what? If we go up, B1 is equal to 12. So it's 12 plus, and the parallel base is equal to 20. So B2 is 20 times the height, the vertical distance between base 1 and base 2, between side of length 12 and the side of length 20. So what do you do here? Just simplify. 2, 5, 6, half times the addition of 12 plus 20 inside a bracket. If you're using the calculator, it will be 16 times h. So h here, it will be 256 divided by 16 is equal to h. So h is going to come down to 16 centimeter. So I'm going to write it here. So h will be equal to 16 centimeter. And just like we found this formula here between the length of sides in the small trapezium as well as the big trapezium, so it is applicable on every single side. So we can say, if h is 16 here, so we can say that small h is equal to the big H divided by 4. And this one, it will be equal to 16 divided by 4, and h small will come down to 4 centimeter. And to prove it, you're going to say that h small in proportion to h capital, it is 4 to 16. If you divide each by 4, it will come down to 1 to 4, which is the same as any other side, or the proportion between any other sides in the small and the big trapezium. Okay, since we found h now for the small trapezium, we can find the area, right? So let me write them here. I don't have space anymore. So B1 is equal to 3 centimeter, and B2 is equal to 5 centimeter, and we found small h as 4 centimeter. So area of the trapezium equals to half, in brackets, the addition of the two parallel bases, so it's 3 plus 5 times the vertical distance between the two parallel bases, which is 4. So if you calculate it here, it will be 0.5 times, in brackets, 3 plus 5 times 4, and the answer will be 16 centimeter squared. If they want you to find the ratio between the big and the small, so you're going to say, I'm going to call this, sorry, not as area capital, I'm going to call it as area small. If they want you to find the proportion between A to A capital. What is A that we found? The small a, it is 16. And what is the given area of the big trapezium? It is 2, 5, 6. Now you are going to simplify by dividing each by 16. If you divide each by 16, this will come down to 1 to 16. And to 16, yeah, 1 to 16. Okay, This is a very interesting question. And here, calculate the area of trapezium A. So we already did that. And I showed you how to do it. Okay. And here, work out the ratio of area A to area B. We also did that up here. Okay. So if we want to do it again, sorry, if you want to do it again, calculate the area. So here we said that B1 is equal to 3 centimeter, B2 is equal to 5 centimeter, and H small is equal to 4 centimeter. Okay, so area of the small trapezium is half, in brackets, the addition of the two parallel sides, so 3 plus 5, times the distance or the vertical distance between them. So when you insert this on the calculator, or if you calculate it by yourself, it will be 16 centimeters squared. Now, they want you to find the ratio between area. So here it's like the ratio of A to big B, right? To big A, sorry. So small a is 16 centimeter squared, and it's given to us that area of the big trapezium is 256. This is given to us in the question, 256 centimeter squared. And we are trying to find a relation between the two numbers. So 16 to 256. So you're going to simplify this ratio by dividing each by 16. 16 divided by 16, it will come down to 1. And 256 divided by 16, it will come down to 16. So it is 1 to 16, the ratio between the area of the small trapezium and the area of the big trapezium. Thank you so much for watching this record. It is very important that you watch it multiple times until you understand every single step in this question or in this record. And yes, that's it. Thank you, and I will see you in the next video or in the next record sometime soon. Thanks.